black box that's not exposed to third-dimensional stimuli like photon energy from the sun, somewhere along the line that atom's got to reach stable state. Is it not so? Now that would mean is that somewhere along the line that electron velocity would have to remain at a constant velocity. Is that not so? Sure. And that constant velocity of the electron says that that atom would reach and maintain in a stable state. But that's illogical. Uh-oh, watch out, Stan. That's illogical. Does not that atom have mass?
Yeah.
Is it not 1/1840th the size of the proton? Does it have an electrical charge?
Yeah.
Does it exhibit an electromagnetic field? Does it move through an electric static field? All of those force factors says that the velocity of that electron would eventually slow down in orbital velocity and attach itself to the surface of the proton. Come on, physicists. You know that there are force factors that's opposed to the movement of that electron. But under the law of physics says it reached stable state. The velocity, the orbital velocity of the electron is constant. How is it then that that electron, which is true, remains at a constant velocity? But the force factor says, no, I'm opposing the movement of that electron. Energy has got to come into that atom somehow to maintain the orbital velocity of that electron. Is it not so?
Right.
Now, just as our eyes had the abilities to see energy frequencies, which we call light energy, or energy by which we see, does not say that there's not other energy sources that are present. Did we not invent the ultraviolet lens and the infrared lens to detect those frequencies of existence? Just as we have done that, the atom has the abilities to detect energy coming in to the third dimension in order to maintain it. And we call it ether energy, or we call it vacuum space energy, or we call it universal energy coming from the throne of God. Now, the law of physics, we go down in the nucleus and we say the smallest particle inside the nucleus are what? Quarks, right? And we, well, and so.
Well, some
And then
people
they
say that.
yeah, okay. So we got quarks. Then they say, well, what's holding the quarks together? Well, we got gluons. Well, what the heck is gluons? They're energy pathways. They are. What's maintaining the orbital spin of the nucleus of the atom? Go ahead. We go back to the gyroscopic action of the nucleus of the atom. You know, when you put electrical stress on here, it now translates electrical stress to these orbital particles inside the nucleus, and as a result, just as the forces are opposing the movement of the electron, I'm now using voltage to slow down the movement of that electron, and I'm not. And as I'm deflecting the electron and changing the time rate of the electron, as I'm moving it and slowing it down, am I not now starting to slow down the gyroscopic action within the nucleus? Is that an abnormal condition? Is that not a destabilized condition? And just as the opposition to move that electron and keep it at constant velocity, I'm now using voltage to oppose the movement of the electron. And as the gyroscopic spin within the nucleus, the 100 particles or so, slows down in orbital velocity, then it opens up the energy aperture and allows the energy to come into the atom. Now that energy aperture in vision is this much like that of a black hole in space. Where a black hole is vortexing, is now allowing energy transfer from one dimensional time zone to that of another. There's no secret to it. All you have to do is understand the triggering process, the native intelligence of the combustible gas atoms to get it accomplished. How is it that you can get energy and release it in the gas combustion process? Where's the energy coming from? You know, when I presented this to 79 of the lead scientists of the world at Geneva, and when they realized that we were doing voltage, guess what the questioner was asking? Where's the energy coming from? We assume it was being consumed or absorbed from the electron, but you're restricting the electron. Where's the energy coming from? Well, scientists of the world and presented the lead physicists of China and the rest of them there, it's coming from the throne of God. It's coming in the third dimension. It's coming through the nucleus of the atom. And then the energy is now be transferring out to the electron level and allowing the electrons to go to a higher energy state, K, L, M, and N, and O orbits. Go ahead. Ah, boy. Lord, you're really doing something good. You see, we got to release this high energy in such a way that we don't have gamma radiations. That we don't have harmful radiations, but we're duplicating the same energy release as the combustible gas atoms normally, but we're just setting up a condition to not allow the hydrogen and oxygen atom to completely form in a water molecule, to allow this energy to be released. Now, by exposing the combustible gas atoms to high voltage, you're restricting amps. Now, you're not allowing amp flow to go into the process. Remember, we're restricting it. Therefore, we're using the voltage, opposite voltage potential, and when you put the electrical stress from the electrons transferring in to the nucleus, you're now oscillating the energy aperture. You are now bringing it into a non-stable state, and what happens is that when you apply this opposite voltage potential, you're oscillating the energy aperture, and the energy coming in the third dimension, it says to the atom, I need this additional energy, and it comes in. Now when you terminate that voltage, the aperture closes, and it's a one-way valve. And you know the potential of energy coming in is greater than the third dimension. Now, to tell you a little bit more about the existence of this, you know, an electron...
No time for discussion.
You've got about 5 minutes.
12 minutes.
2 minutes.
Oh my. Oh boy.
No time for discussion. I wish to pose the
Okay.
questions.
What we're doing now is oscillating the energy aperture. It's a one-way valve. It's allowed to come in. To a nuclear device, you can take an electron, you can run it through a resistor, you release an X amount of heat. The proton 1,840 times greater in size than that of the electron, so that energy going through destroying a proton or taking the energy from it is 1,840 times greater. So normally there's not enough energy in 1 cubic foot of mass to blow up anything. Basically what happens is your uranium's 238s and 235s, they group the protons together to form the vortexing of the energy, and when they detonate it and bring it into critical state, all they're doing is ripping open the energy aperture and allowing the flood of energy to come in. Another way to prove this out, ask the question of how energy is really being developed through the lightning. When lightning is, a bolt of lightning is going through the sky, or across the sky. Go ahead. All right, now we're doing the same thing with the oxygen atom.
Let's discuss a little bit the technical side of your invention. We are interested in the technical side.
Well, that's what I'm doing. So if you be quiet, I'll go on. Otherwise, you can leave, and then I'll go on. Right? So now we're exposing the combustible gases as well as the oxygen atom. We are now priming the combustible gas atoms to a very high energy state. Go ahead. Prior to gas ignition. Go ahead. Now this is an example of that we're adding photon energy to the process. We're now priming it by the energy process, universal energy. We're now causing it, plucking off the electron. So we're taking the combustible gas atoms now in a very high critical state, which now we're priming it, we're setting the condition, we're processing hydrogen oxygen atoms, and we're now going to trigger it. It's a triggering process. Go ahead. And now we've set the condition on the hydrogen fracturing process. So just the same thing as we had on the muon process. Note that on the muon process, we were plucking the electron. Do you remember? Mm-hmm. This was ejecting its natural electron. We went to a muon, as you see here, and it decayed. And therefore, we decrease mass, energy equals mass times the square of light. We decrease it and allow energy yield to increase. Now, what are we doing here? All of a sudden, we plucked off 4 electrons of the oxygen atom. We have added laser energy to it to prevent the atom, the oxygen atom, to go back from stable state. Is that a normal state?
No.
No. Therefore, we're now exposed to hydrogen atom to photon energy. And what happens is that when it absorbs it, it causes the electron to migrate farther away from its nucleus. As a result, is not the electrical attraction force between the electron and the nucleus weakened. So therefore, the hydrogen atom is weakened. So he and I go out on the basketball court. He's the hydrogen atom, and I'm the big oxygen atom, and I zap him with laser energy. Zap. He's in a weakened state. You see, his electrons migrated farther away from his nucleus. Now, I'm the big gigantic oxygen atom, right? I'm many times bigger than you. But I have 4 missing electrons. And you don't like us, And so you ignite the gas, and you come to me to stabilize. And your basketball is electron, and I need to stabilize in the process. And when that happens, all of a sudden I see your electron, and I latch on your electron because I want to stabilize. And so my positive charge protons react on your positive charge nuclei. And when I latch on your electron, who's going to win out? Me or him? I'm going to win. Now when I pluck his electron, are you any more a hydrogen atom? No. He's a measly little proton. And all that energy stored in there with the electron, you've got to start to release that energy. And so this hydrogen atom starts to release its energy, but it's still not in a stable state, and now it goes into an opposite effect, or mass density increases. An avalanche effect occurs because it can't stabilize in the water molecule and starts to release this enormous amounts of energy. Go ahead. Bear with me the next 5 minutes so I can do this. Now, how do we system engineer it into production? Okay, now we're taking the water, we're taking the ionized gases, we're taking the non-combustible gases. We are now producing a fuel mixture and now exposing it to a high pulse voltage frequency to release its thermal explosive energy, as we talked about.
Now, so you might wrap it up in 1 minute. We got somebody else in the lecture here.
Oh my. Okay. Well, I guess we'll go on a little further. Those who are interested, if we can get another room or something, we'll go on to the final stages of this to show how we're taking it into the engineering stage. Thank you. The velocity, the orbital velocity electron is constant. How is it then that that electron, which is true, remains at a constant velocity? But the force factor says, no, I'm opposing the movement of that electron. Energy has got to come into that atom somehow to maintain the orbital velocity of that electron. It's not some black box. It's not exposed to third-dimensional stimuli like photon energy from the sun. Somewhere along the line, that atom's got to reach stable state. Is it not so? Now that would mean is that somewhere along the line, that electron velocity would have to remain at a constant velocity. Is that not so? Sure. And that constant velocity of the electron says that that atom would reach and maintain in a stable state. But that's illogical. Uh-oh, watch out, Stan. That's illogical. Does not that atom have mass?
Yeah.
Is it not 1/1840th the size of the proton?
Mm-hmm.
Does it have an electrical charge?
Yep.
Does it exhibit an electromagnetic field?
Mm-hmm.
Does it move to an electric static field? All of those force factors says that the velocity of that electron would eventually slow down in orbital velocity and attach itself to the surface of the proton.
Mm-hmm.
Come on, physicists. You know that there are force factors that's opposed to the movement of that electron. But under the law of physics says it reached stable state.
Right.
Now, just as our eyes had the abilities to see energy frequencies, which we call light energy, or energy by which we see, does not say that there's not other energy sources that are present. Did we not invent the ultraviolet lens and the infrared lens to detect those frequencies of existence?